Good day everyone, another day to learn something new. Today we will discuss about the differential equation. So, part of the differential equation, today we will talk about the first order differential equations, which is homogeneous, variable separable, and exact differential equation. So, we will focus on the variable separable. What is the variable separable differential equation? It is
So now let's talk about variable separable differential equation. If by algebraic process m times x comma y dx plus n times x comma y dy equals 0 may be written in the form m comma x dx plus n comma y dy equals 0, where m sub 1, m, and n sub 1 are functions of the variable as indicated. Then the variables have been separated. Hence, the general solution can be obtained by integration, where c is an arbitrary constant x cubed minus over y cubed. So we will basically cross multiply all the dy and all the y components and x components. So y cubed dy equals x cubed dx. After that, we will proceed to integration. So let's proceed to integrating. So the integral of y cubed dy equals the integral of x cubed dx. So the integral of it is y raised to 4 over 4 equals x raised to 4 over 4 plus c. So we can remove the denominator by multiplying the equation to 4. So it will be y raised to 4 equals x raised to 4 plus 4c. So let's let c sub 1 equals to 4c. So our final answer for it will be y raised to 4 equals x raised to 4 plus c1. So another example of variable separable is dy over dx equals y plus 3 over x. So let's proceed to answering. So we will divide, or we will multiply the equation by dx. So the answer will be is dy equals x plus 3 over x dx. So now let's proceed now with multiplying it with 1 over y plus 3. So dy, the answer for it is 1 over y plus 3 dy equals 1 over x dx. So now we can integrate. So the integral of 1 over y plus 3 dy equals the integral of 1 over x dx. So that's ln y times y plus 3 and equals ln x plus c. So we can remove ln by using e raised ln y plus 3 equals e raised to ln x plus c. So we can cancel due to loss of logarithmic. We can remove the ln. So y plus 3 equals e raised to ln x times e raised to c. So y plus 3 equals x. So the ln will be cancelled. Raised to times e raised to c. So let c1 equals to e raised to c. So find y plus 3 equals c sub 1 x. So final answer will be y equals c sub 1 x times x minus 3.
Now, we will proceed to homogeneous differential equation. What is homogeneous differential equation?
Homogeneous equation. A homogeneous equation is a first-order differential equation in the form of dy over dx equals f function of x, comma y is homogeneous if it does not depend on the x and y separately, but only the ratio of x over y or y over x. Homogeneous equations are in the form dy over dx equals f times y raised to x. So, to solve the first order homogeneous differential equation, there are steps to follow. So, first, or number 1, perform substitution using v is equals to y over x and dy over dx is equals to x times dv over dx plus v. Next, our second one, number two, solve the resulting differential equation using separation of variables. And number 3, solve the original differential equation in terms of x and y. So, to further understand it, let's try some examples. So let's proceed to the example of homogeneous equation. So dy over dx equals 4y squared plus x times y over x squared. So let's try if it is, or let's check if it is a homogeneous equation. So let's perform dy over dx equals 4y squared plus x times y over x squared. It will be times in, it will be multiplied in 1 over x squared, both the numerator and denominator. So we will get dy over dx equals 4 times y squared over x squared plus x times y over x squared. So it satisfies the condition that it is a homogeneous equation. So now let's try to eliminate excess x and factor 2 from the equation. So dy over dx equals 4 times y over x raised to 2 plus y over x. So now we can proceed to solving the problem. So according to the guidelines or the rules, dy over dx is equals to x times dv over dx plus v, and y over x is equals to v. So x times dv over dx plus v equals 4v squared plus v. So let us put the v on the left side to the right side. So x times dv over dx equals 4v squared plus v minus v. So as you can see, we could eliminate the 2v by subtracting it. So our formula now will be x times dv over dx equals 4v squared. So now we could multiply it by 1 over x and 2 and 1 over 4v squared and dx, or as we can see, let's put all the with v variable on the other side and x variable on the other side, or cross multiplication. So we will have 1 over 4v squared dv equals 1 over x dx. So now let's proceed. So 1 over 4 v raised to negative 2, we just put it on negative exponent because we reciprocate, or we put it up the variable b. So, times dv equals 1 over x dx. So now we could proceed to integrating both sides. So the integral of 1 over 4v raised to negative 2 dv equals the integral of 1 over x dx. So the integral of it is negative 1 fourth v raised to negative 1 equals ln x plus c. So now, as you see, we substitute v. So now we will return it back to the original form, which is x over y. So or y over x rather. So negative 1 over 4 times x over y. It will be, as you see, it is been reciprocate because the variable v raised to 1 is uh you know it's raised to negative 1, so this reciprocate to x over y. So let's proceed. Equals ln x plus c. So we could cancel the denominator by multiplying it by negative 4. So x minus y equals negative 4 ln x minus 4c. So as earlier, we let the value of c to be c1, or let c1 equals to for negative equals negative 4c. So x over y equals 4 ln x plus c1, or let's reciprocate the value let's reciprocate, it will be y over x equals 1 over c sub 1 minus 4 ln x. So we could cancel the denominator or the value of x on the other sides by multiplying by x. So y over x equals 1 over c sub 1 minus 4 ln x. So the final answer would be y equals x over c sub 1 minus 4 ln x.
Now we will study about the exact differential equation. So what is the exact differential equation? It is
Exact equations or exact differential equation. A differential equation m times x comma y dx plus n times x comma y dy equals 0 is an exact differential equation if the left side of the equation corresponds to the differential of some function of x and y. F type x, function of x and y equals c, then the partial derivative of x dx plus partial derivative of d of y dy is equals to 0. So exact differential equation is, it is said to be exact if and only if the partial derivative of m is equal to the partial derivative of n. So example for exact differential equation, we have a given y squared minus 2xy plus 6x times dx minus x squared minus 2xy plus 2 times dy equals 0. So let's find what is m and n. So m is equals to y y y squared minus 2xy plus 6x, and n is equals to negative x squared plus 2xy minus 2. So let us remember to find if it is exact differential equation if the partial derivative of m is equal to partial derivative of n. So let's find the partial derivative of m. So the partial derivative of m is equals to 2y minus 2x plus 0, or equals to 2y minus 2x. It comes from the answer from y squared minus 2xy plus 6x. So now let us find the value of the partial derivative of n. So, negative 2x minus 2y minus 0 is equals to negative 2x plus 2y. So, as you can see, the partial derivative of n and partial derivative of n is equal to each other, meaning it is an exact differential equation. Let's proceed to solving the exact differential equation using m times x comma y dx plus n times x comma y dy equals 0. So we will use the partial derivative of f. So we will use the value of m as the partial derivative of f. So y squared minus 2xy plus 6x. Now we will perform integral, or we will find the integral of the given. So the integral of partial derivative of f equals integral of y squared minus 2xy plus 6x is equals to f equals y squared times x minus 2xy times x squared over 2 plus 6x squared over 2 plus function of h y. So we could cancel some numbers from the given. So our formula will be f equals xy squared minus x squared y plus 3x squared plus function of h of y. Now let's find the value of function of y, function of h of y. So partial derivative of f equals x times 2y minus x squared plus 0 plus partial derivative of function of y over partial derivative of y equals 2xy minus x squared plus partial derivative of y. Now we have the value of partial derivative of y. Now we will equate it to the value of n, which is negative x squared plus 2xy minus 2. So as you can see, there are similar terms that we could cancel, which is negative x squared and 2xy. So we will have negative 2 equals partial derivative of y. So now let's integrate the formula we have. So integral of negative 2 partial derivative of y plus equals partial derivative integral of partial derivative of y. So negative 2y plus c equals function of y. So f is equals to x y squared minus x squared times y plus 3x squared minus 2y plus c is equals to, or our final answer will be x times y squared minus x squared times y plus 3x squared minus 2y plus c.
So always remember to study hard and practice well. This is Gerald Z, Acain Jr. Thank you for watching. See you next time.